welcome back. Now let's perform the NPV and the financials for our project, our PROARP project, as discussed earlier. Now, we're going to assume that you've created a business case, and in the business case, these are some of the things you put in to be able to provide a justification on why this investment is a reasonable investment for the organization to put its money and its resources into, right? Now, let's run through our summaries again, right? The PROARP project, the summary cost estimate. Our initial investment cost is going to be one time, and it will take 850,000 US dollars. This is going to be incurred in year 0. So put 850,000 US dollars. Right, that's a negative. Our operational cost every year beyond that, which we'll expect to run from year 1, will be 200,000 US dollars. We'll have 200,000 US dollars, right? And then we pull this across till year 5, which is going to be the final period, right? Now, so let's look at how much would be expected to save annually, right? So we see our aircraft on ground waste reduction or aircraft on ground reduction will be 378,000 US dollars. Technical delay reduction will be 315,000 US dollars. This is our savings or benefits. Our unplanned maintenance delay reduction will be 845,000 US dollars. And then component scrap reduction, which is what we have been doing, that have been costing us this much, will be 225,000 US dollars. When we add this up, it comes to 1,763,000 US dollars. So let's enter this. These are the savings we're going to have annually, right? So let's look at our annual savings. Of course, our annual savings would begin in the first year. We'll have 1,763,000 US dollars as our positive cash flow. It's a positive cash flow because it's a saving. In other words, we are using these investments to put together tools, systems, and processes that would save us this amount of money annually. And so when we pull this across down to the 5th year, the next thing we'll be expected to calculate will be our net cost or our net savings, right? Now, of course, in the first year, our net cost will be 850,000 US dollars. Let me make sure that I have this full screen mode, right? Our first year net cost will be 850,000 US dollars. Sum of 850,000 US dollars, which is our initial investment cost. And then when we pull this across, we would have our net savings for year 1, 2, 3, 4, and 5, which will be about 1.5 or 1,563,000 US dollars. Another very fantastic thing we can do can be to sum this up towards the end of the sheets. So we could sum this, that at the end of the period would have our initial investment cost will come to 850,000 US dollars. Our operational cost will come to 1 million US dollars. Our savings annually. Okay, so we've also taken liberty to add across. So if you look at the data here, you can see that at the end of the period, we would have spent 850,000 in terms of cost. Now, this will be adjusted for NPV, right? So this 850 would likely will consider all of the NPV impact. In other words, this our total cost would not necessarily be the total cost at the end of the five or the six periods if you include year zero, right? But let's calculate the return on investment. This is a total summed, right? Just simply arithmetically across the years. Now, let's first of all figure out our benefits, right? Our benefit, our net benefit will simply be the sum of each of the benefits of each year. So we're going to sum the benefit across each years, the net benefits, right? And we have 7.8, right? And then let's look at the cost, in which case return on investment, we're going to be looking at the investment cost, right? But if we make this a negative figure, if we take this, it's going to be a negative figure, and I want it to be a positive figure so that we can have an ROI that's not distorted by the signs. So I'm going to use ABS for absolute, which will convert this value into a positive figure, 850,000. Then the return on investment by formula is going to be benefits minus cost, and all of that divided by costs. And you can see our return on investment is 8.19, or over 819% in return on investment. So we can write what? We can simply transfer this here. Is the return on investment for the whole of the project, right? 8.19 or 819 at the end of the period. Now, the next thing we want to do is our net present value, right? Now, the whole idea of net present value is to ensure that, okay, let's begin this way. At the beginning of every project requires negative cash flow. Negative cash flow is used to purchase equipment, is used to secure regulatory permits and get the plants up and running, hire whatever we need to hire so that the investment or the project activity begins. So generally, initial points in a project is usually massive negative cash flow. Now, when the project gets to the operations and maintenance period, it begins to generate cash flow, right? Or positive cash flow. And usually this is at the end of the investment period. Now, this positive cash flow that is going to be end at later years. In this case, we have year zero, negative cash flow. Year one, positive cash flow will generally not be the same as will generally not be the same as the same value of that money if it was earned in year zero. So let me explain what I mean. Monies earned at future time period always have less value than money earned at earlier time periods. So $100 given to me today would be more valuable than $100 given to me next year. Why? Because the $100 I receive today will buy me more goods than $100 I receive next year. And this will, of course, be due to factors like the loss in the value of money over a period of time. Now, what NPV does is that it factors in the loss in the value of money such that every money is earned in future will be discounted by a rate that reflects the rate at which the value of money would reduce, right? So all of these monies we see, so we have 850,000, and then we have each and every one of these as our net savings. These are our net costs and these are our net savings. But when we apply the principles of NPV, each of these monies that are earned in the future times will be deflated by the discount rate of 12%. Now, the formula to take each of these monies earned in the future periods and bring them down to the present value would be converting to present value will require you that you take the future value, which is all these values, divided by 1 plus the interest rate, which is our discount rate, which is 12% right here, and raised to the power of the years in question. So let's do a very simple NPV calculation, which is our present value. This is our present value, right? Now, this is all present value, right? It's when we sum everything that we'll get our NPV. So present value or future value divided by 1 plus interest rate or discount rate, which is 12%, log this with an F4, and raised to the power of the year in question, right, which is year 0. And when I hit enter, and this is what I get in NPV. And then, of course, you would see that the positive cash flow would reduce. My absolute reference would make sure that that 12% continues to be reflected here, right? So in this case, it's going to be raised to the power of 1, right? Raised to the power of 2, you can see that all the monies we're going to be getting in the future. Oh, I think I did not do something correctly. Hold on. I locked this. Raised to the power of the years. $1.3. Okay, so it's properly reflected now. Okay, so that's it. So we've been able to reflect that, and you can see that even though we seem to have received even though we seem to have received 1.5, I mean, our net savings is 1.5, 1.5 in year 1, 1.563 in year 2, 1.563 in year 3, and until year 5. When we discount by 12%, you can see that these monies will progressively reduce in value, such that our NPV at the end will be 4.784 $4,784,265.20. Now, this is really what we consider to be our NPV. So this is going to be our savings. Now, remember we had a cost that is preventable, a cost that we were incurring, right, which was about 7 points, right, 7 million. So let's look at our data sheet, right? There was a cost we were incurring back then. The cost according to our statements, right, the annual cost, total opportunity cost. So these were the areas that were inefficient that we are trying to fix. But we have 7.225, right? 7.225 million or 7,255,000. So let's get in here and write, and it's per annum. So we have 7,225,000. That's the amount that is the cost that we could have prevented. Now, this is what this would have cost us all the while. Let's drag this. Right. Now, we can't factor in this year because this was the year before we started the project, year 0. But this is where we begin to have our saving, right? Where it will be possible to prevent the cost. So you can see across a period of 5 years, this was what we should have expected, right, on those inefficiencies. But this is our savings, right? So one of the things we can do, again, can be to calculate the NPV of the cost that we would have spent. So if this was what we're going to be spending annually, then what would be the NPV of these costs eventually, right? So we have future cash flow divided by 1 plus our interest rates, right? Or interest or discount rate, depending on how you want to call it, raised to the power of the year in question, right? So this is what we're going to have, and then when we pull this across on 7 million, 7.225 million. Let me confirm. So this is going to be our NPV, right? This is going to be the NPV of, so even though, yes, at face value, it looks like as if over that 5 years we would have spent 36,125,000. When we adjust to present value, then what we'll be spending, cost preventable, this is not net present value, this is more of present value. The present value of cost preventable will be 26 million. So let's look at what our net cost will be after implementing the project for 5 years. Our net cost, therefore, would simply be that we'll take this way, we'll subtract our savings. And you can see that, oh, I think I messed up the formula here. So let me undo Ctrl Z. Ctrl Z. Right. Okay. Now, okay, I think it has calculated that. Ctrl Z. Right. So let's take this off. Right. Now, if this is let me put it down here. Now, if this is the value, the cost, the present value of the cost we could prevent, and this is the savings, it means that instead of us to pay or to spend 26 million over a period of 5 years, we'll spend 21,260,242.86 over a period of 5 years, because within that same period, we'll be extracting savings of 4.784 million. And this brings us to the end of this section. And I hope that we understood. I hope that we enjoyed this section of the class. Thank you very much for being a part of this discussion. And I'll see you in the next video. Bye for now.